Hi, welcome to part 2. So let's take a look at how we find a common interior. Now, same like the last one. This time we have a circle. And this time, my favorite, it's a cardioid. We love cardioids. They're hearts. Good for Valentine's gifts. Matter of fact, every year I give my wife an equation like this. Because I love her. Alright, so first thing I want to do is I want to graph the circle. Now, the graph the circle is really not that bad. This is going to be a circle on the x-axis. And it's going to have a diameter of 3, so I can kind of graph this one real quickly. Circles are easy to graph. But the cardioid, I will take a little bit more time to graph that one. So for the cardioid, if I set up my table, theta and r, 0, pi over 2, pi, 3 pi over 2, 2 pi. And what I'm going to do is I'm just going to plug them in. If I let theta be 0, cosine of 0 is 1. That puts me at 2. Pi gives me 0, so I'm at 1. So pi over 2 puts me at 1, right? So at pi, so I'm facing pi. Now pi is what makes it a cardioid, because if I plug in pi, I get 1 minus 1, which is 0. That's what makes it a cardioid right there. And over here it is symmetric, so that's going to give me 1, and that's going to put me back to 2. So when I graph this, now I'm going to exaggerate a little bit here, okay? We're going to go out, here's my cardioid, out, and like so. There's my cardioid. Now, I'm looking at the common interior. So in other words, I want the area between these two right here. Okay, this is kind of a tough one to do for us. So what's going to happen now, when I'm looking for this area here, I am going to set it up almost the same way I did last time. I'm going to, but we want to be really careful, because when I do my radial arm from here to here, right? If I do my radial arm on the shaded region, I'm going to be on the cardioid. But as I rotate my radius, what's going to happen is I'm on the cardioid, I'm on the cardioid, I'm on the cardioid. But then once I hit this point, I'm no longer on the cardioid. I'm on the circle itself. So for this problem, we will be needing 2 integrals to solve this one here. So, in other words, to get this area, we're going to need the area of the cardioid first, plus the area of that circle. Now, we're not on that circle for very long. As you can tell, see if I kind of draw my radial arm right here, we're not on that circle for long. Okay? Matter of fact, it's only a little tiny sliver that we got to find on both top and bottom. There's only a little tiny sliver that we have to find on the circle, but we are on that circle nonetheless. So if I set up my integral, this is not too bad. For the cardioid, it's just 1/2. 1 plus the cosine of theta squared d theta, plus for the circle, 1/2 3 cosine theta squared d theta. Now, notice, I set it all up. So the setup I never think is very hard to do. The problem is, now we got to get our domain. We got the cardioid plus that little part of a circle. And remember, to get the circle, because I'm on the cardioid for a bit, but then after a certain point right here, I'm on the circle now. So what we have to do is find this point where they meet. So again, we're going to find the intersection, because the intersection will tell us about my graph right here. Finding out where the 2 will meet, I set the 3 cosine theta equal to 1 plus the cosine theta. So again, we get the cosine of theta this time equals 1/2. And we get pi over 3, and where's cosine equals 5 pi over 3. Now I'm going to make this as negative pi over 3, because we talked yesterday about when you deal with cosine, sometimes you want to use the negative instead. So it's meeting up here at pi over 3, and down here at negative pi over 3. So let's talk about the cardioid. So for the cardioid, if I extend my radial arm, my magic windshield wiper, from here to here, I'm on my cardioid from negative pi over 3 all the way to pi over 3. So the cardioid is pretty easy. It's just going to go from negative pi over 3 to positive pi over 3. Now, the circle is a lot tougher, because the circle, I'm going to start at pi over 3. The circle starts at pi over 3. So for the circle, we're going to start at pi over 3. But where do we end? Now, what I would suggest is just go to the x-axis right here. So let's take a look at our circle point right here. The problem with circles is that they go around twice between 0 and 2 pi. So if I'm going from my theta, my r, for my circle, cosine of 0 is 1, that gives me 3. Pi over 2 puts me at 0. Pi puts me at negative 3. Right? So if you notice, we're going around the circle twice. So that pi, it puts me back here. So it's going around the circle 2 times. So we don't need anything beyond this. So my suggestion to get the circle part, go from pi over 3 to pi over 2. Now, this is only our half a circle. That's our half circle right there. This gives me, if I keep going, will give me my whole circle. But I don't want the whole circle. I only want the part of it. So because that's my half a circle right here, I need the bottom part as well. I just multiply this answer by 2, and that's going to give me the bottom. That gives me the bottom of the circle by multiplying it by 2. Now, it's not the only way to do this. Sometimes you could write it this way. 1/2 or 1/2 negative pi over 3 to pi over 3, 1 plus the cosine theta squared d theta plus 1/2. If I start at pi over 3, I could go to 2 pi over 3. And that's actually going to give me from pi over 3 to 2 pi over 3. It's going to give me this other point right here, which becomes 3 cosine theta squared d theta. A lot of ways you can write these, just kind of tricky, so please be careful, okay? And if you have any questions, please feel free to let me know, message me, okay? Bye-bye.